Let's look at finding the domain of any quadratic function. First off, finding the domain and the range of a quadratic function can be done without really graphing it, as long as you understand the basic ideas of the graph. Remember, a quadratic function is going to be a parabola or a bowl shape, either opening up or opening down. The graph continues on both sides from left to right, so it is going to the left forever and to the right forever, whether it opens up or down. Therefore, the domain would be all real numbers, because you're going forever to the left and to the right, no matter what the function is. The only exception to that might be an application where within the application wording, they restrict the domain. The more interesting part is that this graph is not going to go up and down forever. Because it's a bowl shape, the vertex is going to either be at the lowest point or it's going to be at the highest point. So if you know the vertex, you're going to be able to look at those domain restrictions quite nicely. But you need to know whether the graph opens up or down. So let's take a look at these two examples to figure that out. Well, in the first example, f of x equals 5.5 times the quantity x minus 2 squared plus 9, we have a positive leading coefficient. That means the graph is going up, and therefore the vertex is a minimum. It's the lowest point. So if I can figure out what that vertex is, which if the graph is written in vertex form is pretty easy, take the value from inside of the parentheses. Remember, switch the sign. So my x value of the vertex would be 2, and then the number outside would be that's added on or subtracted would be my y value. Sign stays the same. So my vertex here is 2, 9. The 9 is the y value. That's my lowest value on this parabola. So my range would start at 9 and go up to infinity. We would include the 9 as part of the graph, and remember, with infinity, we always use a parenthesis. In the next example, I have g of x equals negative 3 times the quantity x plus 1 squared plus 5. Here we have an a value that's negative, so the graph is going down. So the vertex is now the highest point. Well, let's identify what that vertex is. Again, the x value is from the inside of the parentheses, negative 1, changing the sign, and the y value is from the outside term that you're adding on, and you keep the sign, that's 5. So the vertex is negative 1, 5, and the y value would be 5, and that's my highest y value. So that means the range at its highest is 5. And it goes down to a negative infinity, so that would come first in my range in interval notation. So the range would be negative infinity to 5, including the 5.